Sounds good.
Sounds okay. Going live. Okay. So hi everybody. Welcome on this Sunday to Diffusion Architecture live stream with Julian Besems. Julian is a lecturer at the Bartlett School of Architecture, UCL, and he's also a PhD candidate at ETH Zürich. He is on the B Pro MRH Urban Design program at the Bartlett. He teaches as the science skills tutor for Research Cluster 11, and he's conducting his PhD research at the Chair for Digital Architectonics ETH under Ludger Hovestadt. Before pursuing a PhD, he worked as a junior architect at Balmond Studio. He holds a master's degree in architecture from UCL and a bachelor's degree from Newcastle University. In addition to his architecture studies, he completed a BSc in computing science with a minor in mathematics at Radboud University. His research focuses on the domain of digital architecture, and particularly how computational literacy can change the way in which we think about architectural design. So Julian, welcome. The floor is yours to your presentation, and we're excited to have you here because you have really cool, interesting work. So go ahead.
Thank you very much, Daniel, for the introduction, and thanks for having me. So I'll share my screen and give a short introduction to my work. So I've prepared a short kind of statement, more a mix of, let me just make sure that this is, it's more of a mix of a theoretical introduction to the things I'm currently researching in relation to my PhD, but also framed to kind of all the projects that I think are still relevant in that light. So I've named it Castle of Accessible Abstractions. Hopefully that will become clear why I've named it like that at the end of my little talk. So the first thing I want to really discuss, which I think is important when we think about what architecture is in relation to a digital theory, is how we actually represent architecture within a digital encoding. So I think we can all agree that the dominant way in which we work with architecture in a digital context is predominantly a 3D model. So we look at architecture through the 3D geometrical definition, and from that, it mediates all the different forms of communication, which we derive from that singular 3D model, whether that be renders, plans, sections, or even animations. They're all inherently mediated by this singular definition in Cartesian space. And I would argue that this is starting to become non-sufficient. Now, even if we're now saying that we can work with diffusion models in relation to architecture, like these are still dominantly used as image representations of a geometrical notion of that architecture. However, if we go back to Vitruvius 2,000 years ago, is saying in his 10 books of architecture what the education of an architect should entail, it's not just this geometrical notion of what an architecture is, but it goes beyond that, because architecture also inherently has to deal with the culture surrounding it, the context, and the politics. So what he says is that the architect should be skillful with the pencil and instructed in geometry, but also know history, philosophers, music, medicine, jurists, and astronomy and theory of the heavens. So I think taking this into account now that we're starting to really work with architecture in a digital format where it's not just a representation, but it also becomes a platform within which we start developing design methods, how might we start opening up this realm to be more than just geometry? Now, with machine learning, a very simple example of how this might go beyond that geometrical definition is looking at, if we just take a pre-trained model of mobile net, so a neural net which can represent an image into 1,000 feature vector. So for instance, if we take an image of a Japanese garden here, Ryoanji in Kyoto, we can represent that in n-dimensional space. So we're not limited to these 3 dimensions of Cartesian space anymore, but we can represent it into n dimensions, here being 1,000. Of course, these numbers don't really mean anything, but it does allow us to start comparing things. So if we then take two other gardens here, another Japanese garden, Senkei-en, and an image of an English garden, something interesting starts to happen. Because if we think about this on a geometrical plane, then you might argue that this English garden and the Japanese garden on the left are much more similar. They both have a pebble garden with circular elements in them and a vertical wall structure at the back. However, if in this encoding of n dimensions we start comparing them in the distance, we actually see that the two Japanese gardens have a distance of 0.5, whilst both the Japanese gardens to the English garden have a distance of 1. So they're further away, which obviously this is a super small sample and illustrative kind of experiment, but it does show us that being able to encode something into more than just these linear relations of a geometry does allow us to go beyond that and start capturing some form of qualitative aspects, be it cultural or otherwise. And this then also leads me to a quote by Yunya Ishigami when he was talking about his design of the Kate workshop, is that what he particularly highlights in that design process is that he sees promise in this in something as indefinite and ambiguous as a cluster of stars becoming oriented in a very particular and enduring image or state. I see in this in kind of accessible abstractness. Now, you might not think of Ishigami as the most prominent digital architect. However, I think this is a very promising way to think about architecture in a digital context, because we start being able to draw connections and constellations and proportions between things which are abstract. Like we can't quite say why they are related or why they are like that, but they start stabilizing in a certain way that we find accessible or pleasing. And I think this is kind of the thing that I would like to strive for in terms of a method of designing in architecture within a digital context, looking for this wave of representing accessible abstractions between those relations. So then, continuing with this challenge of encoding architecture within a digital context, if we look at Koolhaas in Elements of Architecture, he highlights how the understanding of architecture is not just a discussion of space, but it's actually, we speak about the plan as being the conceptual document of orthogonal projection, but actually, even though the art of making the volume inside those containers is one that surprisingly is never discussed. So as architects, we are concerned with space, but we don't have an immediate way of actually defining space. We define space through this relationship of the plan and the section and how they stand in relation to each other, being two domains that we can't, they are non-commensurable. We can't project one plane into the other, we can't translate them because they have to stand in orthogonality to each other to give rise to this understanding of space. And then if looking at the domains of current encodings within machine learning, the first one, if we look at all the existing artifacts that we use as training data, we might understand this as the rational numbers in a mathematical sense. So we input these as discrete elements from which a new kind of relation is derived through the regression of the machine learning algorithm. But then the resulting domain that we get is continuous. It's probabilistic. It's not the same as the original. It can't be translated into that, but it's a probabilistic continuous space, which we might understand as a set of the real numbers. What is interesting about this is that it opens up a larger space because we can interpolate between everything. There's something in between all of these things. It's continuous, but it's not inherently new because it's still related to what the original input is. Now, if we think about what the real numbers give us, and in relation to the rational numbers, it's a change in cardinality. So we can't make a projection between the two. There's a leap, but in proportion or in a set, there's still something missing, which I would argue is in the complex numbers. So, and the real numbers and the complex numbers, the main difference there that we want to take into account is that if we treat them as sets, they're isomorphic, they're the same. We can make a projection, which might look something like this, and we get two-dimensional planes. So you can represent the complex plane as a plane. We get a projection between the real numbers and the two-dimensional like this. However, as soon as we go beyond a set, but into group theory, and that entails adding operations or transitions to the definition of a mathematical set, they are completely different. And I think this is where we should start seeking in terms of an architecture within the digital is how, and relating to machine learning, how do we start creating operations? How can we start creating relations between these things that go beyond a pure distance measure? And then a short reflection on the current state of stable diffusion and diffusion models is that if we think back to Foucault talking about Magritte's paintings Ce n'est pas un pipe, he says something interesting where what misleads us in the fact that this pipe is not a pipe and the language is not the same as the image and the image is not the same as the actual object is that what misleads us is the inevitability of connecting the text to the drawing. As the demonstrative pronoun, the meaning of the word pipe and the likeness of the image all invite us to do here, and the impossibility of defining a perspective that would let us say that the assertion is true, false, or contradictory. And what's fascinating in the diffusion models is that text and image are embedded in the same space. There's a translation and a collapse into the same vectorial space. They are no longer standing in proportion to each other where they are different domains, but they actually are in the same embedding from which we can extrapolate from text an image, or with clip, we can extrapolate a matching sentence from an image as well. But that is because they are collapsed into one thing. However, if we want to go into the domain of the complex numbers, we should start looking where this translation is no longer a translation, but a proportion to different things. And I'm sorry, but it looks like my, oh no, it's not crashed, great. So the point is that as a complex plane, a complex function from a complex plane to another complex plane, we can't actually draw. We can't represent that. We have to represent the codomain, which we can see here, which we can do by coloring, to be able to show what a transformation does to the other plane. So if we take the original domain being represented like this, so that's a flat complex plane, and we have a function, a complex function here, we can plot that by understanding what every point from here is mapped to into the other space, because we have a two-dimensional function to another two-dimensional space, creating 4 dimensions which we can't visualize. However, we can visualize it if we start defining what the original domain is and where that is mapped to. So starting to create relations between these two different entities. Then going back to Ishigami in terms of what that might mean in terms of an architecture in the digital. So in this interview, where the interviewer asks him, so to you, computerization or an information-oriented world, things like that aren't reasons to try creating a new base. And I think what he says here is very interesting, where he goes on, I guess I don't think it can be done. Not meaning, of course, that there isn't going to be a base. I just think since the base and the output have to be working simultaneously, they naturally ought to be built at the same time. So in the same way that we have the image and the text, or the plan and the sections, neither one of them becomes the base in which we design, but they have to constantly stand in relation to each other. We have to think about the image as the image and the text as text in order to start creating proportions and create new understandings of those which aren't just a translation. Now, one example project which I think that I've done, which is by no means a perfect execution of these things, but maybe starts experimenting with these notions of projecting between domains and relations between things that aren't in the same representation, is this project which I did for my master's, where I took all the Flickr photos in Venice that I could find over 10 years, which I think ended up around 200,000 photos, which you can see here, and deriving locations from that, pairing it with all of the photos from Tate and MoMA, or art pieces from Tate and MoMA. From that, I started to create relations between those, and for each location in Venice, a custom art gallery was created based on the collection being curated to what the photos taken in that place were. So take all the photos in the place, get the entire collection of Tate and MoMA, create a collection based on synergy of photos and visual characteristics to then create an organization of similarities, which you can see here. So then the root of this, because I didn't want to place one art piece as above any of the others, becomes a generated art piece based on the entire collection. So for instance, here, these are a set of generated art pieces. This is done a couple of years ago, so no diffusion models yet, but just GANs. But these serve as the root and initiate an organization of qualitative aspects represented as art pieces within this certain location. Then from that organization, I started to, as such as I would say, project qualitative relationships between all of these art pieces and in relation to its context and what people made there onto a geometric definition within that site. So here, scrolling through that very quickly, we have the organization of all the art pieces based on that hierarchy to which spaces were fitted. Circulation was created through algorithmic means, after which a completely defined art gallery was created. So I see this as first taking the qualitative domain of art and photos in Venice, projected onto a geometric definition. So this is not the geometry is not a singular outcome, but each gallery is the same singular design, ending up in 1,297 different instances, different projections of this overall establishment of how I would create a gallery based on this method. So here we can see all the different galleries, or here based on how many different art pieces there are, based on the original plot, where they are, what the root of the organization is, the materiality, the organization, and the placement, and the views that were framed are all based on this synergy between qualitative aspects, art, and a geometric projection onto the site. Now, yeah, so this is another image of that, where the root of the generated art piece, which forms the root of the organization, sits at the back and the art gallery in the front. If you want to see the full project, it's on there. And then I'll very briefly go through. So now in teaching, this is the exhibition of the cluster that I'm teaching from last year's show. We try to do similar things with students where they start looking at data sets, they gather their own data sets, and they start understanding how these different data can be related to each other, how you can juxtapose them, and especially how you can create biases. Because I think in a general data science approach to machine learning, you'd want to eradicate biases because you want to create a general model. However, if we design with data, the creation and the choice of what the bias is allows us for a creative agency. It allows to sculpt kind of the relations that we're interested in. So I'll skip one project, but this is a project where they were interested in the question of what top-down and bottom-up theory is in a city, so it's an urban design project, and how the conflict between these two paradigms actually gives rise to interesting investigations. So they took 50 books of top-down and bottom-up theory and started to talk to these books. So we have a self-organizing map of Kublai Khan, which is the name that they gave to the character of all of their I think 100 books. And they start speaking to him. So they get opinions from Kublai Khan, which is top-down, and Marco Polo, which is bottom-up. And from that, they create different opinions. They create different opinions from theories, after which they create an amalgamation of texts, map these onto projects by OMA on ArcDaily, and project those back onto a self-organized map of elements of Istanbul to get mood boards of what designs might look like based on the interests that they have in the project, leading finally to a short conceptual exploration of if both of them take this entire method that they took. I mean, it's a very brief version of their project. What would they create? So they start with an input of what they want to make. They get opinions from all of these different books on what that might be. So they create an overall hierarchy of how they search, how they move between the different data sets in order to start proposing a project from that. So finally, to end with another quote from Foucault, is that within architecture, I think this very much applies, is that the problem is no longer one of tradition of tracing a line, but one of division of limits. It's no longer one of lasting foundations, but one of transformations that serve as new foundations, the rebuilding of foundations. And I think this is essential to understand, is that all these outputs that we get from machine learning, they are not necessarily outputs, but it's actually, as architects, how we start creating methods to work with these entire new domains and how to put them into proportion and into context and start relations and affairs between them. That's how we might start thinking of how to think of what an architectural project might be, rather than taking the output as such as a foundation for that. Okay, thank you. Sorry I went a bit over time, but that's all.
No, that was cool. Thank you, Julian. That was really interesting. And just to like kind of like go back a little bit, because one of the key things that you talked about, at least that stood out to me, was the idea of like feature encoding something, right? And then feature extraction, and then finding some way to take that information and transform it into another domain, and form like some sort of relationship. So from that context, can you maybe talk a little bit about how you see feature extraction in the context of what you're doing? Like, does it actually serve the purpose that you're doing? Because you talk about like adding like the bias specific, right? So you have to like kind of like tailor what you're exactly extracting. So talk a little bit about that, like the feature extraction part.
Okay, so I think there's multiple ways of looking at this. So if you use, for instance, a mobile net or clip or an existing model, then you already have the way in which these things are kind of emphasized. So for instance, mobile net, I think, was trained on 1,000 different categories of elements in images. And then it says, okay, it's so much probability this thing and so much probability that thing. And because of that, you get an interpolation based on these 1,000 anchor points. You can start speaking about what that thing might be and how they relate in a distance from one to the other. That's obviously a very generic one, but if you take all of that, take those features as they are, but with a very specific data set, and then after that, use a self-organizing map or something else to recontextualize them, you still have means of kind of extrapolating these into a different space. Although probably if you have a very specific goal, it would be better to train it from scratch or retrain it specifically. So what I did for the Venice project, for instance, is that I took all of these Tumblr photos, Flickr photos, and then put those based on geolocations, put those into different locations on Venice. So I did like recursive algorithm that splits up the division of points, and if it's a uniform distribution, it says, okay, that part is one location. So I got 2,000 different groups of photos. And then I retrained MobileNet, fine-tuned it. So chopped off the last, I think, 3 layers or something like that, and gave it, instead of the 1,000 original categories, I gave it all of these 2,000 locations. So you have 2,000 locations, each with buckets of images. Some are only 10 images, some are 500. I mean, some Mark Square have a lot more photos than some random alley. So you get different numbers, which is not ideal for a training perspective, but actually it kind of serves the point for the level of resolution that is desired for a project like that. So then it allows me to then say, okay, based on all of these qualities, I can then feed the entire collection of Tate and MoMA into that and make custom collections of art pieces based on how that image classification model says, okay, this one is most there. That's a very discrete way, because then you just take the best hit for each art piece according to those locations of photos. But you can also then do this with a self-organizing map. If you, for instance, for the students that I was talking about, they use TF-IDF to vectorize all the books, and then they made a self-organizing map to be able to say, okay, Marco Polo has a point there, and Kubla Khan has a point there, and you kind of see how the concepts travel through this overall domain of data. So I think this question is mostly at this point still for me at the stage where you're investigating how can you represent a domain of data in a similar way to how can you represent the domain of the complex numbers in order to understand what these functions are between different domains. So that's how I would kind of think of it as a broad overview and what the featureization is. But it depends. If you want something super specific, then retrain it. If you want something where you kind of just need a way of representing a domain, just take a pre-trained one. Like it's at the end of the day, as architects, I think it's more important to start working with the data rather than become data scientists. That's probably not what we should be doing.
Yeah. I think one of the in relation to that, one of the things that I thought was really interesting, at least from like your thesis project, is the idea that you did do this kind of like feature encoding, but what happens is like if you have over 1,000 or like whatever scale of images you have, then at that point you can't do that by hand. So you have to develop this algorithmic process to be able to generate like those filters or thresholds. So you can actually, use the data in some way, right? But you have to like set some, I guess, some parameters or some thresholds. Um, what do you think about, I guess, like the use of AI and algorithms in like design? Because you're doing it from like a different kind of, I guess, like top-down perspective where you're planning out the whole system, right? Versus like a bottom-up approach in some way. So what do you think about like kind of automating the design process with algorithms?
So but this is, I think, the interest that I'm also speaking about with Ishigami is like his creation of accessible abstractness. So I think with all of these tools, we shouldn't think about automating design as automating the generation of a 3D geometry. I think the 3D geometry is just one instance of the design. So it's a projection of the design. So the way that I see that gallery project is actually it's one design. It's not 1,297 different galleries.
Mhm.
Those are just different projections of the same design. So I would say it's being able to design within abstraction and being able to start crafting relations that go beyond geometry is where the architectural notion within this digital architecture should sit. Is that it's not automating the creation of buildings. I think it's being able to think about what an architectonic relation is between different things and how they sit in proportion to each other is what an architectural project in a digital context might be. And whether that becomes a geometry or not, that's a different question. It can, but that's just one instance of that. And that I don't think means automating the process because that would entail that you can then generate any building. But I think that's kind of not the question. You generate any building of that singular design, but it's still one design. In the same way that when Koolhaas speaks about the concept of space, he also in that same page he says that probably most architects don't know the cubic meters of the most iconic spaces in the world because that's not what we're interested in. I mean, the space might be slightly different, and we'd still value it in the same way, but it's the proportion, the overall architectonic gesture and quality that we're kind of engaged in, and that doesn't change whether that definition becomes more multiplicitous or not, I think.
Yeah. No, that's an interesting point, because, for example, you see, I guess like the use of these image generators to for people to try on like or you know approach things in a visual sense, right? And be able to develop kind of like design options or so on for like inspiration. But one of the things that the vision models lack in some way is it's kind of like this extra dimension of relationships and how you would actually experience the space, right? Or at least like human can imagine it, right? Like if you look at an image, you can more or less put yourself in there. Um, Now, when you're encoding all these things, from your approach, it's like your main interest just to figure out ways to generate novel relationships in some sort of process, like algorithmic process, or Because at least that's what I see, but I want to see what you think about that.
Yeah, I think that's pretty spot on. It's maybe not generate, but it's how to discern. So how can we formulate new relations, or how can we formulate associations or contextual associations between things? So, for instance, one experiment I'm doing now, and also with my students, is that they are working with text and images, but they translate text through to an image by film. So they take the subtitles of a film and the context within which that subtitle is being said, and then take the image which goes with the text to see what kind of correspondences you get. So then we're not saying that, like, Magritte, this is not a pipe, or that the image is not what the text is, but we're actually looking at, in a space, what do we talk about in a certain space? What do we say in a certain space? And then it becomes contextual and it becomes associative. And I think these kind of transitions are might be very interesting to broaden the level of being able to just translate from, I want a chair that looks like an avocado, which is kind of one of the initial examples, but why would we want a chair that looks like an avocado? In what context do we want that chair? And what does that chair have relations with? What text does it have relationships with, or what other objects or images or ideas does it come with? And I think these are kind of the notions that I'm interested in exploring. And also, this is work at Chair of Digital Architectonics with Ludger Hovestadt and the other PhD students and postdocs, is what they've been doing for a long time. So I think some 10, 15 years ago, he kind of rephrased his chair to look at what is architecture if computers can do what we think architecture is. I think these kind of things and these notions of what becomes an architectonic gesture is what I'm mostly looking at and I'm interested in terms of these embeddings and encodings and translations between things. Sorry, I lost track of your question a bit, but I think that's that's
No, that's cool.
Started out with.
Yeah, and I think, like, if we look at it also from like the encoding side, so you use EfficientNet, and there's obviously like more developed algorithms that are, learning things unsupervised. So I think EfficientNet, if correct me if I'm wrong, but that's based like on a supervised approach, right? Where you have categories or something like that.
Yes.
Yeah.
Yeah. Is it MobileNet, and then that comes from, I don't know. It's one of those fairly early kind of image classification models, because also this was the one that I used for the project, which was now 4 or 5 years ago. So,
yeah. And I think so, like, looking at what the trend is kind of going, where like it's more now of like these unsupervised methods, right? Where like there's little human supervision and annotating data, and you have models like, for example, Dino, right? That takes, I don't know how many images. I don't know if you're familiar with that one, but it's like learning unsupervised by like mask patches. So it's trying to predict like the mask. I was just gonna ask you, I was gonna ask you if you have explored kind of like more of these unsupervised methods where you're not necessarily labeling the data, or maybe it's like a GAN or something, but you're using that representation that is gained in a supervised way to be able to process it into something else.
Yeah, I mean, so one thing that one student of mine is now working with, which we've discussed, and they're doing this in their project, is using Clip in combination with Segment Anything from Facebook. So and this is quite nice, where they have a text library of a couple of thousand books, which they've completely analyzed based on sentence by sentence using, I think, using Clip. So they get a Clip representation of all the contents of all of these thousands of books. And at the same time, for their project, they're looking at image of the site. And then what is very nice is that using then Segment Anything, you can break up kind of all the elements in what is in these images of the site, and then put those back into Clip and annotate what these images are based on their data set. So you almost start facilitating how that data set of text might look at these images, because you're not you take the Clip embeddings, but you don't use a generic Clip labeling data set, but you use books that have meaning in terms of the context of your project. So you start creating these automata that allow you to look at things from a different perspective of a very curated data set. So kind of those sort of experiments we're working with them in that way. And yeah, I think that's one example of an unsupervised learning. I mean, I think the SAM, the segment anything, that must be an unsupervised model. So that might be one example of how to use that.
Yeah.
And it's kind of it's in the game of crafting how to use these things to stage a view or a kind of a narrative in a very particular way that goes away from kind of the general model, but becomes a personal interpretation of how these things interact on their personal project. That's, I think, the most the main interest that we're working with.
So like the main idea behind this is to kind of fine tune those models on your specific data set. So like I think you said like you can bias it in a relationship of, or like the direction of relationships, right? Essentially.
Yes, I think so.
Cool. And then yeah, go ahead.
But yeah, it's not just fine tuning the existing models, but also start finding ways of relating different encodings of different types of media in custom kind of functions. So for instance, the film that I mentioned, or the film idea, or the now with this, that you start being able to look at an image by segmenting it and encoding that in clip, but only labeling it with your custom data set. So there's no machine learning fine tuning happening anywhere in this entire process. But it's actually because you use specific information to input into these models, you can still use them to give you kind of personal results and personal outcomes.
Yeah, it doesn't. That's pretty interesting, because that's like you almost have, like, if you're working with it, you have to, at least you have to know like you can manipulate them later downstream in some way. And maybe talk a little bit about, I guess, like what, like if you're like an architecture student, because I think you do teach for architects, right? Like how do you open them up to be able to explore these tools in a way that it's not too foreign, let's say?
Yeah, yeah. So that's the program that I'm teaching on is part of the B Prime, so the Bartlett perspective, which has a fairly long history on kind of computational teaching. So it's a computationally driven program, set of programs which are the architectural design, architectural computation, and urban design programs. I'm teaching on the urban design one. And each of so I think there's about 5 or 6 different clusters per program, and each of them have their own take and their own brief and their own specialty. So students come in, and it's a 12-month program. So they're with us for 12 months, starting in September, ending in September, pretty much. And in that, during the first 2 terms, so in the UK we've got 4 terms then this way. So it's like up to Christmas, Christmas to Easter, Easter to summer, and then the summer term because it's a 12-month one. For the first half of the year, they learn skills. So next to starting their project and starting to define what the overall brief is and what they're developing, we teach them skills. So usually there's 3 different skills tutors. I'm one of them for RC11. And I teach them Python. So I literally start with the basics, and I start teaching them how to program, what is a vectorial encoding, what is vectorial space, how can you actually think about these things. So kind of from the basics, but along 4 or 5 main topics. That's what I teach. And then someone else, Seal, he actually teaches them kind of mathematical foundations of computer science. So what does it mean in a mathematical sense, like in a theoretical way, to be able to start thinking about these concepts in a more abstract level, to get an overview of what does it actually mean to be able to communicate with these things on a numerical level or in a computational method. What is the complexity of an algorithm like, and what is an algorithm actually, which are quite it sounds very fundamental, but it's important to start being able to be literate in these things in order to be comfortable designing with them, where you're not just using these things as an endpoint, but you start probing into them, you start using it within your overall understanding of what a project is. So yeah, it's we literally just start teaching them the basics of computation for a couple of months. But it's a lot of self-taught as well. So they have to engage with that, and they have to kind of start looking at their own things. So we only give them a handful of kind of starting points. And then if they want to segment anything, then they have to say, and then we help them, but they have to kind of initiate that. And then we really encourage them to start looking on GitHub and actually download these things, get the code and run it locally and kind of work with it to be able to fine tune it, not in a machine learning fine tuning, but in a kind of fine tuning to slip into kind of the overall project method.
Like the inputs and outputs.
Yes. Yeah, I think we've only had one group that really just they made their own complete neural network from scratch, but that's rare. That doesn't usually happen. But I mean, they can if they want to, but generally it's taking existing networks, existing models, and reuse them in different ways.
Yeah. And what do you think about like this kind of approach to like a multimodal model where now you can get text, images, let's say maybe even video, but also audio. Have you explored kind of like those few modalities in projects or within like kind of your research?
I mean, the proper kind of general AI ones that do video, sound, image, and text, I'm not familiar with if you can actually run those locally yet. Maybe I've been sleeping on that, but not those. But I think yes, they do use, the students do use diffusion models and as the kind of the image to text or text to image. But then I think for me, the most important thing is that you then start being able to work within the text. If you create from text to image, then it's not about just giving one text, but it's about giving a family of text, or how to construct a prompt that creates something, how to create that on an abstract level within the overall method, that you can create prompts for any specific different situation that you don't manually craft. But so kind of start interacting with that on a slightly like one level above the actual input. So where you start working with that. Because what I was kind of saying in the presentation, I think the limitation of, I mean, if it's Stable Diffusion or DALL-E or Midjourney, is that all of these embed image and text into one single vectorial space. And I think that's a massive limitation, because that just means that the image and the text are essentially the same thing within that, the translation of the same element. And I think that is inherently a limitation of these methods. And also, if you listen to a interview with Jan Le Cun recently, is that he kind of also highlights this, that the entire, what these diffusion models have enabled is actually that they can suddenly work with images, but actually they're doing that through text, through large language models, through all of these things, because before that we had GANs which never quite reached that level. And it's because of the language element that these things are now able to do that, but that also means that the images aren't separate from the text anymore, and they don't offer another level per se of kind of understanding of what the project is. So of course they form a translation, they form a rendering, and it's a different understanding than a text, but they don't open up another whole way of working, because it's just one representation of what the text input is. And that be understood, I think, in order to work with them on that level. So which is why I was saying, if you work with them on an architectural level, I think then you need to start understanding what the text is in order to be able to understand what the images are.
Oh, interesting. So you actually think from that, because it does make by, I guess, like jointly training like the images and the text, you're collapsing their representation into a single kind of like
Yes.
point within a vector space. And from that sense, it does make sense. Like it is much harder to understand how you can kind of disentangle the text from the image and some sort of representation. But I think like something that is interesting too, which is kind of like what you mentioned in your presentation was like the idea of the plan and the section, that you
Mhm.
can't work without the other one, right? Like you kind of have these two, let's say they could be like modalities, right? Like you're looking at a section is from one view and then the plan is another view.
Yes.
And so what do you think about that in coding? Because as architects, in some way, we do have to work with those representations in some combined way, right? They're always updated
Yeah, exactly. No,
together.
absolutely. But this is exactly why I think
Yeah.
just the fusion models, because they collapse into one singular space, doesn't give us the means to create full architecture. Because in
Yeah.
the same way that the text, no, the section and the plan, you can't collapse them quite into one thing. You might argue that a 3D model does that, but also not really. There's something more to the understanding of what a plan is and orthogonality
Hmm.
to the section. And I think this is also what text and images are. Like the image, um, we look at an image and it has a different quality to us than a text. And finding those proportionalities that go beyond just the translation, I think is a very important question in order for us to kind of work with these type of methods and machines. And I think this is also then kind of the new challenge to look at within these different models and how to understand what that translation is, what those embeddings are, how we can use them in a way that they are still separate and that the image is still something different from the text and that it offers something different from each other.
So you would say like in some cases like it would make, at least for like the type of research that you're doing, like to have just kind of like a separate, like fully or it could be like some specialized like vision model and then another one text model, and then you can still process them in some way together, or be able to have those relationships.
Yeah, I think it's the question of crafting those relationships
Yeah.
in order to be able to work with them in different domains and have each domain remain non-commensurable to the other and be kind of like the complex, where the complex plane becomes valuable and becomes an extension to the real numbers by
Hmm.
operation, by the way of operating between them, by being able to craft functions that go beyond just a set, that go beyond distance. And I think this kind of understanding is something that creates an architectonic relationship and creates an architectonic understanding which is not inherent in a distance-based translation.
Yeah.
I think that's kind of the challenge, and that doesn't mean that we can't use these things or that they can't be relevant, not at all. But there is something more to think about in terms of embedding architecture within the digital than just creating kind of these projections through translation, where in the same way that text and image are kind of non-commensurable, and text can offer
Hmm.
something more than an image, and vice versa. And this is also kind of what I was referring to earlier as an experiment. Like what do we talk about in context to
Hmm.
something? And that is probably not something that you're going to get from a diffusion model.
Right.
I would be very surprised if you could make a diffusion model that would immediately create a set in which you would say something, because it doesn't really it doesn't arrive at a singular definition, because you might sometimes say something completely different in a different setting. And whilst a dog always looks kind of like a dog,
Hmm.
saying something happy can be said in the same place as something sad, very simply said. But there are still relevances to these things and kind of synergies and relations that we might think of in that way.
Yeah. Cool. And then I guess just coming up to the hour, so just a few final questions. What do you think about, for example, like the Sora model or the idea of being able to craft these video narratives that can be like a minute long, right? And I would argue in some sense that they do become spatial in some way, right? Because you are kind of moving out through space. Have you thought about like what the impact of something like this might be?
I mean, I think the impact will be massive, but
Yeah,
I would still, I'm still wondering what that is as a space for an architectural project,
yeah.
because well, it becomes a space and it becomes animated, and you can take that space, you can put it into a photogrammetry, and you can create a 3D model from it. So of course, but it doesn't. I don't think that that immediately becomes an architecture
Hmm.
in that way. In that the architecture also needs an understanding of how that space is kind of lived in, how it's animated, how it relates to its context, and all of these things. Whether and some of those things might come through in the Sora, and I think in the Sora models, and I think it's fascinating how it's able to capture that in a movement. But then still the question is, how do you start activating that? How do you start prompting it with the things that you actually want? Because if then the Sora does become space, then the creation of that space sits in the text that you give it or the images that you give it in order to make those films. But that still means that there is a spatial and architectonic understanding before you actually go to that step, I would
Hmm.
argue, because otherwise, it's still only going to interpolate between things that are already known. So yes, it
Yeah.
can create a Western scene, which I think was one, or a woman walking in Tokyo,
Hmm.
which was kind of one of the first images. But those already exist. Like we have films of women walking in Tokyo and films of
Yeah.
Western. So it's still going to sit in that continuous space between all of the things that are already there. But how to actually use that to create new things and create new understandings of space and new architectural relationships, I think is the main challenge. And that doesn't really fundamentally change whether it's a video that has a geometrical nature or whether it's an image, I think. But that's, yeah, we'll see where that goes. I'm very curious. I'm very excited about it. I think it opens up a way of working that goes yeah, it goes much beyond kind of crafting three-dimensional models by hand, but it might still require a lot of crafting of understanding what that space might be in a similar way. I don't think that will disappear at all. So,
Yeah. And what's interesting is kind of like the introduction of a camera, right? That becomes your sort of tool in like this model because now you can craft the camera and that should give you
yeah.
some sort of 3D spatial condition. Okay, Julian, I think we're coming up here. So final words, like what would you recommend kind of like students looking into this space of AI in architecture and design? And yeah, do you have any advice, words, or things that you might want to share with somebody?
I mean, I think getting into any of this, the most important thing for students will be to start actually understanding the basics. So I think rather than playing around with the endpoints, start understanding what these models are. What is a vectorial embedding? What are these vectorial spaces? What is a distance between things? How can you start creating relations between what you input and what you output? And that you can only do that if you have a notion of a kind of the mathematical background, but also just the basic computational level. So I think understanding those parts is fundamental. So super simple linear algebra and digital theory, I think, are actually more important than being very clever with prompt engineering or something like that. I think it's that would be my advice. I think you gain much more insight into how these models operate and what they can and can't do and what they're capable of, and how you can then start playing around with those and rephrase them and put them towards your own personal implementation rather than the generic one that already sits there, which you don't really have much control over. I think that's yeah, to me that's the most important thing to start thinking about.
Cool. And do you recommend any books or references that you find really useful for this or that? you use for your own
Uh,
inspiration?
Let me think. I mean, one book that I think is that my students have loved as well, and that came out recently. It's by the chair where I'm doing my PhD. So he did his PhD there, Miro Roman.
Mm-hmm.
It's called A Play Among Books. And there he kind of sets out how to start thinking about representations of text in a architectonic way,
Mm-hmm.
or an architectural way. I think that's a very it's a very good kind of book to start understanding how to work with abstract things like text, but in the context of architecture, and the digital and the computational. But that's a more kind of architecture theory one than a crash course into Python programming. But I think for that, just
Yeah,
start
you can
looking,
go online.
go online, look at YouTube tutorials or whatever.
Yeah.
Yeah, that would be one that comes up now. But, yeah.
Okay, cool. I'll put that in the video notes. Cool. All right, Julian, thank you so much for being part of this. Really appreciate it. And it was really interesting. Like we spoke a bit before and you showed me your project and I was like fascinated because the idea of coming up with like a complex system like the one that you created, at least for your massive thesis, is wild, right? It's coming up with all these pieces to fit together and then finding like a way to think about it architecturally. It was pretty interesting. So thank you again. Yeah, and looking forward to see more of your work in the future. And yeah, that 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 will end the stream here. Thank you, Julian.
Thank you very much for having me. It was a pleasure.
All right.
Bye.
Have a good weekend. Bye.
Weekend. Bye.